Okay, 2006, question 21, component of weight style question. So a van of mass 2,600 kilograms moves down a slope which is inclined at 12 degrees to the horizontal as shown. Calculate the component of the van's weight parallel to the slope. So I'll just do the wee solution underneath here. So part A, component of weight we know is equal to mg sin theta. So this basically tells us the force that is causing that mass, or the lorry in this case, the van, sorry, to go down the slope. So its mass here is 2,600 as given in the question. In fact, I shouldn't write kilograms there, that's not much use, is it? 2,600 times 9.8 times sine 12 degrees. Calculate that out, it'll come out at 5,297.6 newtons. So that is the force that is causing that van to go down that slope. B. A constant frictional force of 1,400 newtons acts on the van as it moves down the slope. Calculate the acceleration of the van. So from Newton's second law, we know that accelerations are caused by unbalanced forces. So there must be an unbalanced force acting downwards to make that acceleration happen. So it must be acting down the slope. So if friction is 1,400 newtons, we can calculate what the unbalanced force is simply by taking the frictional force away from the component of weight acting down the slope. So we're looking at an unbalanced force of 5,297.6 minus 1,400. That will give you 3,897.589. We'll leave it at just now. So we can calculate the acceleration here by doing unbalanced force over mass. That's just F equals ma. So if you put those values in, 3,897.589 divided by 2,600 as our mass here, you'll get an acceleration of 1.5 meters per second squared. So just by knowing Newton's second law there and knowing that unbalanced forces cause accelerations, we can figure out what the unbalanced force is there given the frictional force, and then calculate using F equals ma what that acceleration is. Not too difficult so far. The third part there is similar to the example I just showed you. The speed of the van as it passes point A is 5 meters per second. So just looking back at the little diagram there, it's a measured distance here of 75 meters between A and B. So that already gives us a piece of information that we're going to need. As it passes point A, it's at 5 meters per second. Point B, as it says there, is 75 meters further down the slope. Calculate the kinetic energy of the van at point B. What's your kinetic energy equation? EK equals a half mv squared. So we're going to need to find out what V is first. How are we going to do that? Yep, we're going to use equations of motion. So first thing we can do is write down suvat as we always do. So initial speed, in fact S first, is 75 meters. So it's covering a distance of 75 meters. U, its initial speed is 5 meters per second. V is what we're trying to figure out. A, we've just calculated what its acceleration is. It's 1.5 meters per second squared. And T is an unknown. So we're trying to calculate V. We've got U, A and S, so it's going to be V squared equals U squared plus 2AS again. So U squared 5 squared plus 2 times 1.5 times 75 Calculate that out, you'll get 250. Square root of 250 is 15.8 meters per second. So 15.8 meters per second there. That's not our final answer though, because we're asked for what the kinetic energy is. So we just need to plug that final velocity there into Ek equals a half mv squared. So a half times 2600 times 15.8 squared will come out as being 325,000 joules. And that's your final answer. So 3 marks for that last part. It's a wee bit more complicated because it involves an equation of motion and also involves an energy calculation. The previous 2 parts before that are just standard stuff for dynamics. You're looking at Newton's first and second laws and adding in a wee bit of the component of weight.